Another set of examples. So resolve into partial fractions. A x squared plus x plus 1 over x plus 1 x squared plus 1. So this time it has x squared plus 1 here. So that is not linear. Okay. So because it's not linear,
Boom.
so because it's not linear, then we'll have a over x plus 1 plus bx plus c over x squared plus 1. The idea is you must always have this coefficient here, this constant, the number on top should have the powers of x less by 1 in the denominator. So the denominator should have a higher power by 1. When you're not dealing with linear. To be linear, when the powers of the denominator, when the power of x in the denominator is not 1.
Sir, can you repeat?
Tanya, I'm not understanding this equation.
So earlier on we had something like this.
Me too.
If you have this, we said you could say a over x minus 1, b over x plus 1, because the power of x here is 1. The power of x here is 1. But if you increase the power of x, you make it 2. Then the difference between the powers of x in the constant and in the x squared is 2. We want the difference to be 1. So if we increase this to x squared plus 1, you cannot have a b on top. You have a bx. So the difference between the power of x is 1. And then we'll have a c, because if there's an x, then there should be a constant.
So repeat again.
Excuse me, sir.
Please repeat.
Sir,
Hello?
excuse me. PDF karabo mbapanamde ya seti.
Tanya, I'm not understanding.
Look.
If possible, sir, just teach.
Sasa vai bangana na pamoja bx plus c.
Okay.
Zona.
So listen. In the previous examples, we had very, very nice expressions where if I have 2x plus 1 over x plus 1, 3x minus 4. The interest is in the powers of x. Since in this expression here, the power of x is 1. I can have a constant on top. Since in this expression here, the power of x is 1, I can have a constant on top. This is different from having, if I have 1 over x squared plus 1, x minus 3. I can't say a over x squared plus 1. Because if you try to do this, if we try to do this, we can solve. We multiply x squared plus 1, x minus 3. Then we'll have 1 is equal to a, x minus 3, plus b, x squared plus 1. We expand here, we get 1 is equal to ax minus 3a plus bx squared plus b, which is another way if I don't have number that I can use to get the values. So that we only have one x here. There's no x on the left. So a,
Sir,
you know,
the one you've done per second, you can do the way you did that other one. It's okay.
that other one we had found the variables, some of the variables.
Oh, okay. I thought it was x plus 1 then squared. Then it's just x is squared.
So you have cross multiplied.
For us to get to this,
Yes.
yes, we are multiplying this whole thing by that guy, this by that, and this one by this one.
So are you still showing what could go wrong, or we're using this method?
Hello?
Are you still showing what could go wrong, or we're using this method?
No, we want to find the A's and test if they will be correct.
So we've left the first equation,
Yeah, we've left this one.
x
Yeah.
plus c.
So we are demonstrating here. So we are experimenting on this one, on this one, an experiment. So you say ax is equal to 0x since there's no x on the left, meaning that a is equal to 0. Bx squared is equal to 0x squared, meaning that b is equal to 0. Or negative 3a plus b is equal to 1. But a is 0, b is 0. This is not 1. So already it's not making sense. Why? Because of fixing a constant when you have the power of x greater than 1. So you demand that the power of x in the numerator should always be less by 1 in the power of the denominator. You have seen. That this can't work out. So this is a different type. So you treat it different. So now how do you treat it? Say, okay, you multiply by x plus 1 and by x squared plus 1. So that this part and this part will cancel on this piece here. So we get x squared plus x plus 1. Hello?
What about if we had x cubed? So our b will be bx squared.
Will be x squared plus cx plus d.
Okay, thank you.
Asa,
Hello?
me, I'm not convinced. I'm not convinced on the part where there's bx plus c over x squared plus 1.
Okay, so let's solve them and then test. Since the other one we failed to get a solution, let's see if this one will give us a solution. And then we'll see which one makes sense to help us be convinced. Then now we multiply this piece multiplied by this piece here. We'll get a x squared plus 1 plus bx plus c multiplied by x plus 1. In here, even if we let x to be negative 1, so if we do that, we can find a, but we still have two unknowns, b and c. So the best is to expand. So we have x squared plus x plus 1 is equal to ax squared plus a plus bx times x, we get bx squared, plus bx times 1, we get bx, plus c times x, we get cx, c times 1, we get c. So now on the left, we have x squared plus x plus 1. We put the x squares together. So we have a plus b x squared plus b plus c x, bx plus cx. Since x is common, you factorize it. And then plus a plus c, the constant. If these are equal, then a plus b x squared should be equal to x squared on the left. B plus c x should be equal to x on the left. A plus c should be equal to 1. So now this means that a plus b should be equal to 1. The coefficients must be equal. B plus c should be equal to 1. The coefficients must be equal. And then a plus c is equal to 1. So in any of these equations, we can solve, let's solve for a from the first one to be 1 minus b. Take it.
Sir, repeat what you said on the third last line going down.
So we are equating the powers of x on the right to the powers of x on the left. The powers of x on the right to the powers of x on the left. The constant on the left. So like terms equal to their form on the other side.
Okay. All right, sir.
So,
Sir,
okay, just a minute. Okay. What was the question?
sir, just go through for me how you're doing the a plus b squared to get to a plus 1 equals to 1. How you're finding that?
To get to a plus b is equal to 1.
Yes, sir.
Since in this equation here, we have on the right, if these are to be equal, since we have x squared on the left, we have 1x squared on the left, we must have 1x squared on the right. Because we know that if these coefficients differ, if this is 2, then these two are not equal. So the only way this can happen is when we equate the powers on the right to the powers on the left. So we'll say, from this step, we'll say ax squared plus bx squared should then be equal to x squared itself. So we'll have bx plus cx to be equal to x itself. We'll have the constant a plus c to be equal to 1. If you divide throughout by x squared on top, you get a plus b is equal to 1. If you divide by x, you get b plus c is equal to 1. This one remains a plus c is equal to 1. That's how we get these equations. And when you have them, when you have these equations now, you say, okay, since this is a plus b is equal to 1, I can solve for a here and take it. If I find it here, I'll write it in terms of b. If I find it here, I'll write it in terms of b. So now we have b plus c is equal to 1. Where there is a, it will be 1 minus b plus c, which is there, is equal to 1. So this one, if we take the other side, we're going to have negative b plus c is equal to 0. This means that we'll get c to be equal to b from this equation here. Then now you get this and bring it in the middle equation. B plus where there is c, we have b again is equal to 1. So 2b is equal to 1. So that b is equal to 1 over 2. So a is equal to 1 minus what is b? It is 1 over 2.
Sir,
Hello?
I followed properly, but why didn't you, like, when you came out from a is equal to 1 minus b, why didn't you use the one in between?
There's no a here.
Oh, okay.
Mhm.
So what you did on a plus c 1.
On a plus c is equal to 1. Where there is a, we have said it is the same as 1 minus b. So I'll put 1 minus b because it's equal to a.
Okay.
We are adding c. So now b has been found to be half. And a is 1 minus b. So a is going to be 1 minus half. So common denominator is 2. 1 into 2, you get 2. 2 by 1, we have 2 minus 1 there. And so A is going to be half again. C is equal to B, but B is half. So C is equal to half. This means that,
A is supposed to be negative half.
Why do you think so? One minus half
Just correct.
is positive half.
Sam.
Uh-huh.
So we're only ending up to B plus C over x squared plus 1 because the denominator is only multiplied by like 2 factors.
There's no power here. The power there is 1. If the power was 3,
okay.
it would have appeared 3 times.
Okay.
So that A is half. So we'll have this. B is half. C is half. So we'll have this. X plus 1 over x squared plus 1. Or I write it as you have half x plus half over x squared plus 1. So half is common, so it will be factorized. So we have 1 over 2 x plus 1 plus the factorized half, and then we have x plus 1 over x squared plus 1. So these are the partial fractions that we have. If you resolve this, you find yourself on the left hand side.
Let's finish them, sir.
We are finished. Or you mean something?
No,
else?
sir. So what did you say on the 1 over 2x plus 1 plus half?
We say that the half is common there, so you can factorize it.
All right.
Sir,
Yeah?
I have a question.
Mm-hmm.
Like, I had to keep it relatively. So how did you manage to get bx plus c of x squared plus 1?
Whenever you have a power that is more than 1 in the denominator, what you bring on top should not be a constant. It should be a function whose power of x is less by 1 in the power of the denominator.
So I've got a question.
Mm-hmm.
All right, sir.
Are you sure 1 over 2, when you put A as 1 over 2 over x plus 1, is going to give us 1 over 2 x plus 1? Here.
When A is half over x
Yes.
plus 1, this is the same as 1 over 2 divided by x plus 1 is
1
it?
over x. Yeah.
Over 1, right? If we change multiplication to be the same as 1 over 2 multiplied by 1 over x plus 1. Which is the same as 1 over 2 x plus 1. The b plus b came from c is equal to b. So where there is c, you substitute b. Since we have B plus C, we will now say B plus B.
Excuse me, sir.
You know?
Would it not have been easier if the step that's after the question, if we just started from there to say, we say x is -1 so that it gives us 0, so that when we multiply the bx plus c, it gives us 0, so that we have a.
So that's another method, is it? Which you demonstrate in the other one.
Okay.
So I
Go ahead,
opted to
Professor.
demonstrate also this one, so that then you have a choice to make of which method will work better for you. So how do you know I now need to have a bx on top? You are looking at the powers of the thing that is down here. The difference in the powers of x of the numerator and denominator should always be 1. When dealing with non-linear. Non-linear, when the power of x is not 1, then it's non-linear. This is how you know I now need to have that thing. Someone asked, why did it work in the first question, in the second question that we did? Because there we had x squared, and yet we only put b on top. This x here was treated as a repeating linear because you have x squared out. So it is a linear that is repeating. And to show that it has repeated, we said a over x, and then we said b over x squared. It is this guy which is repeating for it to be squared. But if you have x squared plus 1, you cannot say a over x plus 1 plus b over x squared plus 1. That's not how it repeats when there's a plus or a minus. Okay, so you have a tutorial trainer. They need to end here.
Sir, since the class is recorded, they can come on later.
Yeah, they can come and watch later. Kindly, the class is being recorded. Let's just go as far as we can.
We are finishing anyway, partial fraction. So another example would be the solution is that we finish, or the previous board is here. Those wanted the previous board. So I made with one more example, one more type, and then we'll be done with partial fractions. Partial fraction is only has you only meet it once in exam. It only appear once in exam. If it appears in question 1, you won't find it in any other question. It's just the so we're doing it just about 5 marks here. 2 marks, 3 marks for the partial, and then you integrate it. And I mean another 3 marks. So 6 or 7 out of 100. So you don't have to take much time.
It's out of 100.
Exactly. Okay, so let's
Thank
log
you,
out.
sir.
Let's log out and come back so that you can do the last type that is remaining.